So proceeding with the next numerical, that is fourth question. The equivalent resistance of the arrangement of resistances shown in adjoining figure between the points A and B is. So here two terminals were given, one is A and the other is B. So to be fixed here, you have to simplify the complete circuit and to find out the final answer. So focusing on this, children, let us start from the upper part. In the upper part, we have three different resistors connected in parallel. So first of all, let us try to simplify this. Two different resistors connected in parallel. So let us also simplify this. And then we'll go with the circuit diagram. First of all, solving with the very first part. This be first part and here let us go with second part. So solving for the first one, we have, as the three are connected in parallel, we have to use the formula of parallel combination. 1 by Rp is equals to 1 by R1 plus 1 by R2 plus 1 by R3, where R1, R2, R3 is 8, 16 and 16 respectively. 1 by 8, 1 by 16 and 1 by 16. So 1 by Rp is found to be LCM is 16. 8 goes 2 times, 16 goes 1 time and again 16 goes 1 time. So this is found to be 4 by 16 or 1 by 4. Okay. Yes. So see, if 1 by Rp equals to 1 by 4, clearly Rp must be equals to reciprocal of 1 by 4, that is 4. So the final resultant equivalent resistance of all the three parallel resistors is found to be 4 ohms. Similarly, moving down and solving for the second part, we have again these two resistors are connected in parallel, unequal resistance connected in parallel. The formula is 1 by Rp equals to 1 by R1 plus 1 by R2. So 1 by R1 is 1 by 9 and here it is 1 by 18. So the LCM for this is 18, 9 goes 2 times and 18 goes 1 time. Therefore, the value of 1 by Rp is found to be 3 by 18 and this 3 goes 6 times. So this is equals to 1 by 6 or Rp is found to be 6 ohms. So the equivalent resistance for the bottom part is found to be 6 ohms. So upper part is 4 ohms and bottom part is 6 ohms. Now let us plot the circuit diagram for the above picture. The equivalent resistance after simplification for this is given as, first of all, let us try to fix the terminal A. The 3, after solving, we are getting it as 4 ohms. Already 20 ohm is there. Bottom, after solving this, we got it as 6 ohms connected to a 6 ohm resistor, which is further connected to terminal B. So clearly in the above figure, upper layer 4 ohm and 20 ohm both are connected in series combination. Whenever series combination is there, you have to simply add upon. So 4 plus 20, you will be getting it as 24 ohms, and again bottom part 6 and 6 connected in series together, you will be getting it as 12 ohm. So very clearly we have 24 ohm and 12 ohm, two different resistors are connected in parallel. So the final value must be A, upper it is 24 ohm, lower it is 12 ohm, this is B. When 24 and 12 are connected in parallel, the final value for this after solving, let me name this as some case 3, okay. So this third part, after solving, how much you are getting, children? So 1 by Rp is equals to two different resistors connected in parallel. 1 by Rp equals to 1 by R1 plus 1 by R2. R1 is 24, so 1 by 24 plus 1 by 12. So here we can simplify this as LCM is 24, this goes 1 time and here goes 3 times, 2 times. So 3 upon 24, 3 goes 8 times. So we found that 1 by Rp is found to be 1 by 8. If 1 by Rp is found to be 1 by 8, then Rp must be equals to reciprocal of that, which is equals to 8 ohms. Hence, the final answer for this is found to be 8 ohms, and hence option B must be true. So, what is the final answer, children? 8 ohms. Okay. So, now you are getting into that, I suppose you could able to understand. So, let us simplify it further. So, now moving to the next question, that is question number 5. Again, one more circuit was given, children. You need to simplify this and to find out the equivalent resistance. So, look into that. In the network of resistors shown in the adjoining figure, the equivalent resistors between A and B, you have to find it out. So, let us observe the picture carefully. Okay, here, if you, the next upper part, this 3 and 3 connected in series, again this 3 and this 3 connected in series, again this 3 and this 3 connected, and similarly coming down, these two connected in series, these two connected in series, these two connected in series. Okay, so solving those, let us see what happens. A and B is fixed. So I am just changing the shape of the picture to make you understand in a better way. Okay, so here we go. Terminal A is fixed. I am only changing the shape of the picture, nothing more, I am doing it. So this connection, yes, here is B. Observe the picture carefully, children. Let us start from A. From A we have 3 ohm and 3 ohm in series. Here is your 3 ohm and 3 ohm series. Again down also we have this 3 ohm and 3 ohm in series. So totally 1, 2, 3, 4 resistors were drawn. 1, 2, 3, 4. Moving to the middle part. Again in the middle part, this 3 and 3 are connected in series. Bottom also we have 3 and 3 connected in series. Now coming to the last part of the picture, we have upper side 3 and 3 connected in series. Bottom also 3 and 3 connected in series. So the simplified picture will be as shown. Finally it is connected to B. That's it. So now the picture is very clear. You can simplify this. Well, so what must be the next part, children? From A we have 3 and 3 as they are connected in series. Both series combination, simply summation of this will be giving you 6 ohm. Here also 6 ohm, 6 ohm, series combination 6 ohm. These two again series combination 6 ohm and these two 6 ohm. So let me draw it once again. So fixing the value of A, upper we got it as 6 ohm, bottom also you found to be 6 ohm. Second part of the picture, middle part 6 ohm and 6 ohm, and finally further connected to 6 ohm and 6 ohm as shown in the figure, finally to the B. Very clear, 6 and 6, 2 equal resistors connected in parallel. When 2 equal resistors are connected in parallel, the resultant will be R by 2. So here R is 6, 6 by 2 is 3. Here also R by 2, 3 ohm. Here also 6 and 6 parallel, 6 by 2 is 3 ohm combination. So, the final part of the picture is something like this. The resultant of this is 3 ohm. The resultant of the mid part is again 3 ohm. And the resultant of the third part is again 3 ohm. So, in this picture, it is very clear that three different resistors, three resistors, 1, 2, 3 of 3 ohm each are connected in series. Hence, simply adding upon, we have the equivalent resistance as 3 ohm plus 3 ohm plus 3 ohm is found to be 9 ohm. And hence, the correct option must be option number D, that is 9 ohm. Okay. So, that is it, children. Well, moving to the next question. Sixth question. 4 resistances are connected in a circuit in the given figure. The electric current flowing through the 4 ohm and 6 ohm is. Now, a small difference is there. Till for whatever the 5 numericals we have solved is only simplifying the circuits. But now you are asked to find the amount of current passing through each resistor. So, small, after solving this, we have to again solve the problem. Okay. First of all, let us try to simplify the given picture. Okay. If you observe this carefully, these 2 equal resistors are connected in parallel. When 2 equal resistors are connected in parallel, we observe that the equivalent resistance is found to be R by 2, that is 4 by 2. Here it have 2 ohms. Similarly, here also 2 equivalent resistance, equal resistance connected in parallel, 6 and 6 connected in parallel. The resultant will be 6 by 2 is 3 ohm. So, let me plot the circuit diagram for this. What is the circuit diagram, children? Here we go with the upper part. After simplifying, how much you got? 2 ohms. Here also 6 by 2 we have 3 ohm. So, this total resultant 2 ohm I dropped. This total resultant 3 ohm I dropped. Bottom, it is connected to a battery supplying of 20 volts. How much? 20 volts battery. Okay. So, you are asked to find the electric current in the 4 ohm. Now, in the picture you can't find anywhere the 4 ohm and 6 ohm. First of all, let us simplify this. If you observe this again, this 2 and 3 are connected in series. So, totally the equivalent resistance is 2 plus 3 is 5 ohms connected to 20 volts. Applied potential difference. So, now we have voltage is 20, resistance is 5 ohm. But from Ohm's law we have V is equals to IR, or the value of current you know to ask, I is equals to V by R. What is the potential applied? 20 volts. And the resultant resistance is found to be 5 ohms. So, further solving it, we got the current as 4 amperes. So, how much current is passing in the circuit, children? A current of 4 amperes passes through the circuit. Okay. When 4 amperes of current passes through the circuit, here this 4 amperes is divided. Some part of this is flowing across the 4 ohm resistance and the remaining part is flowing across the second part of the resistance. Because there are 2 equal resistance, 4 and 4 equal resistors, the current is also divided among them equally. So, how much current here? Among 4 amperes of current, 2 amperes is taken by the upper 4 ohm resistors and the remaining 2 amperes is consumed by the lower resistance. Again this 2 ampere combiningly 4 amperes, and 4 amperes again is divided into, split up into the 2 equal resistances, again 2 amperes here and 2 amperes. Together after combination 4 amperes. Okay. So what is the final answer, children? So clearly we have this 4 ampere in each. So what they are asking is the electric current flowing through 4 ohm resistance. In every 4 ohm resistance, half of the current is been passing. So how much is that? 2 amperes of current is passing in each 4 ohm resistance. 2 amperes, maybe this or this. Similarly, again the 4 amperes current is again subdivided into 2 amperes and 2 amperes in the 6 ohm resistor. So above 2 amperes, below also 2 amperes. So in each 4 ohm resistors, 2 ampere of current is been passing on, flowing, and even in the 6 ohm resistance also, each case 2 amperes of current is passing. So here also 2, here also 2. So your final answer is 2 amperes and 2 amperes. Is that okay, children? Okay, so now moving to the next part of the question, that is 7th question. The current from the battery in circuit diagram shown is. You are asked to find the current from the battery. So the battery value voltage is given as 15 volts, which is further connected to a 0.5 ohm resistor, and the remaining part of the circuit is as shown. Okay. So here if you check it out, this is subdivided at A terminal, 6 ohm is connected to 2, and here only these two are connected in series, 8 and 0.5 is connected in series. Here the remaining part 7, 1 and 10 are connected in series. So let us mark this. So these 3 are connected in series, 7 plus 1 plus 10, totally 18 ohms are connected in series, and here also 8 and 0.5, totally 8.5 is connected in series. So after solving this, let us draw the circuit diagram, simplified circuit diagram. Here how much are we getting, children? Somehow we get here as 8.5. How much is that? 8.5 ohms, and here 7 plus 1 8, 8 plus 10 is 18 ohms. So based on that, let us draw the simplified circuit diagram. 2 ohm, 6 ohm, bottom B, upper A, potential difference or voltage applied is 15 volts. Together anywhere I can drop the resistance, it is 8.5 ohm. Combinedly 8.5 ohm I have written, and here all together combinedly 7 plus 1 plus 10, totally we have 18 ohms. That's it, children. So 2 ohm I covered. A part, simplified part is 18, parallel 6, B 8 together 8.5, and remaining is 15. So if you look at this circuit diagram carefully, we observe that 6 and 18 are connected in parallel. So if you simplify that 6 and 18, how much you are getting, children? These two, as they are connected in parallel, we have to apply the formula 1 by Rp equals to 1 by R1 plus 1 by R2, that is 1 by 6 plus 1 by 18. LCM is 18, here will be 3 plus 1. 6 goes 3 times and 18 goes 1 time. So you have 4 by 18. So 1 by Rp is found to be 4 by 18, or Rp is equals to 18 by 4. This is equals to 4.5. Okay. The equivalent resistance for these two is found to be 4.5 ohms. Now, taking the simplified resistance as 4.5 and simplifying further, the circuit diagram will be somehow like this. This is your 2 ohms, and here is your A. Simplified part is 4.5 ohm, bottom connected to B. Well, further is connected to 8.5, and this some potential difference applied across this. And it is 15 volts. That's it. So clearly in the picture 2, 4.5 and 8.5, 3 different resistors are connected in series. 3 different resistors connected in series means the total resistance is found to be 2 plus 4.5 plus 8.5. Hence, the simplified case will be 2 plus 4.5 plus 18 together is found to be how much, children? This is 8.5 plus 4.5 is 13. 13 plus 2 is 15. So, a 15 volts applied potential is 15 volts and the resistance is 15 ohms. 15 volts and 15 ohms. But you are asked to find the current from the battery. As we know from Ohm's law, V is equals to IR. Current I can be calculated as V by R, where the voltage from the battery is found to be 15 volts and the resistance applied is 15 ohms. So, simplifying, you will be getting it as 1 ampere. Hence, the correct option must be option A, that is 1 ampere. So, what is the answer, children? 1 ampere. So, now moving to the next question, that is question number 8. What will be the equivalent resistance between the 2 points A and D? So, where is A? So, this is your A to be fixed. One more is D, here it should be fixed. These two terminals are fixed. Okay. So, further from A 10 ohms, splitting here, again 10 ohms and splitting here C and something like this. But if you observe this carefully, these two resistors are of no use. Okay. Because it is not further connected to any other circuits, this can be ignored, this can be eliminated. These two resistance has no value. So, this can be eliminated. So, now because no further current is passing through them. So, let us try to draw the circuit diagram once again after leaving this C and B part resistors. So, here we go, children. The simplified part, first of all, let us start from A 10 ohm connected to 10 ohm. Between we have again 10 ohm. Further 10 ohm, 10 ohm to D. I just eliminated the C resistors and B resistors. So, what are you left with? 10 and 10 up, 10 and 2 bottom and 10 and 10 parallel. That's it. If you observe this picture carefully, we have that these 10 and 10 are connected in series, something like this series. Here also these two are connected in series. Two resistors connected in series, the resultant resistance will be 10 plus 10, this is 20 ohms here and here also 20 ohms. Hence, the simplified portion for this is, here we have A 10, these two, I will just plot it something like this, these two we get it as 20 ohm, these two also we get it as 20 ohms, further connected to the another value, that is 10 ohms. Okay. So this 10 here, this 10 here, simplified portion 20, simplified portion 20. Very clearly we have 20 and 20 are connected in parallel. When these two are connected in parallel, two equal resistors connected in parallel, the resultant resistance will be R by 2. That is 20 by 2 is nothing but 10. Hence, finally we get the circuit diagram as here is your A, 10 ohms, the simplified part, the simplified value 20 and 20, parallel combination 20 by 2, this is 10 ohms. So, in between we are getting again 10 ohm, and further finally it is connected to one more resistors 10 ohm. So, here is A and here is your D. So, here we clearly observe that three different resistors 10 ohm each are connected in series. So, when three different resistors are connected in series, the equivalent resistance will be summation of that. That is 10 plus 10 plus 10. Totally, it was found to be 30 ohms. So, the equivalent resistance is found to be 30 ohms, and hence the correct option must be option C, that is 30 ohms. Okay. So, well, moving to the 9th question. What is the equivalent resistance between A and B in the figure below if R is given to be 3 ohms? The value of each R is given to be 3 ohms, and you are asked to find out the equivalent resistance between A and B. So, let us focus on A and B. So, here is A and here is B to be fixed. A and B fixing, you have to simplify this. Coming here, resistance, some breakdown is there, okay, two different direction, here also two different direction, but if you observe the bottom part of this circuit, this R and R are connected in series combination. So, let me draw the diagram once again. So, what is this? Here it is your A, here it is your B, or single resistance R, bottom two different resistors are connected in series. First one is R and second one is R. So, these two are connected in series. The combined effect will be R plus R is found to be 2R. Hence, let us draw the diagram once again. This is A and this is B. Here you have R. Here also R, here also R. R plus R is found to be 2R. If you observe this, these R and R, I wrote it as 2R. The above R kept as it is, the sideways R's also as it is. If you observe the picture carefully, we have these two resistors are again connected in parallel. When two different resistors are connected in parallel, the combined effect will be equals to parallel combination. 1 by Rp is equals to 1 by R1 plus 1 by R2. R1 is taken as R, R2 is taken as 2R. So, this LCM we found it as 2R, R goes 2 times and this goes 1 time, this is equals to 3 by 2R. So, the value of 1 by Rp is found to be 2R by 3 by 2R, or Rp is found to be 2R by 3. The value of Rp, the equivalent resistance is found to be, for this it is found to be 2R by 3. Is that okay, children? So, now let us once again draw the simplified diagram for this. What is there? Up you have two terminals A and B connected to a resistance R. Here also connected to R. Further simplification connected to 2R by 3. So, we have three different resistors connected in series. When three different resistors are connected in series, to get the combined effect we have to add the 3 resistors. So when you add the 3 different resistors, this let this be case 2 and here this be case 1. Okay. So this first case I solved, second case if after solving this, the effective resistance is R plus 2R by 3 plus R, or it can also be written as 2R plus 2R by 3. Taking the LCM 3 to 6, 6R plus 2R is, yes, 8R upon 3. But the value of R, they have given it as 3 ohm. So substituting here, we have R is replaced with 3. So 3 and 3 gets cancelled. The final answer is found to be 8 ohms. So what is the resultant resistance? The equivalent resistance of this given circuit, we are getting it as 8 ohm. But here, nowhere we could find the value as 8 ohms. Hence, the correct option must be option number 4, that is none of these, because the final answer is 8 ohms. Well children, now to the next question, question number 10. Okay, so in the 10th question, we see that the current in the following circuit is, so this is the circuit diagram they have given you. So we have to simplify the circuit diagram and we need to find out the current. So which we have already solved these type of models in the previous question. So we can finish up this. So clearly in this, forget about this. These two resistors are connected in series. 3 and 3 when connected in series, the effective resistance is found to be 3 plus 3 is found to be 6 ohm. Okay, and hence the equivalent resistor or the equivalent circuit diagram is found to be something like this. This combined effect I am writing it as 3 plus 3, we got it as 6 ohm. Here already 3 ohm is there. So the voltage across this is 2 volts. That's it. That's it children. Well, arrow mark of course is given. So look at this, 2 volts, 3 ohm. That's it, and 3 plus 3 together 6 ohm I have written. So very clearly this 3 ohm and 6 ohm are connected in parallel. When these two are connected in parallel, the effective resistance is given by 1 by Rp equals to 1 by R1 plus 1 by R2, that is 1 by 3 plus 1 by 6. LCM is 6, 3 goes 2 times. And here is your 1, so this will be 3 by 6. So if 1 by Rp is found to be 3 by 6, then Rp will be equals to 2. What is the value of Rp children? 2. Hence the effective resistance and hence the effective circuit diagram is something like this. The effective resistance 2 ohm . 2 volts. Okay. You are asked to find the current in the circuit. So what is the value of the current in the circuit children? So as from the Ohm's law we have V is equals to IR. I is found to be V by R. Voltage across this is 2 volts and the resistance is 2. So finally you are getting it as 1 ampere, and hence the correct option is option D, that is 1 ampere. Well, so moving to the 11th question, the equivalent resistance of the circuit shown in the figure is. So also simple question children, very clearly you can orally you can solve this. So looking here, looking at that, in this picture 2 equal resistors are connected in parallel. The resultant resistance will be R by 2, that is 2 by 2 is 1 ohm. So after that we observe that 2 ohm, 1 ohm and 2 ohm are connected in series, and the resultant diagram can be plotted something like this. This is 2 ohm, middle part we have 2 and 2, equivalent resistance we got it as 1 ohm, and the last one as 2 ohm. Together they are connected to a battery. So all the three are connected in series combination, and in series combination effective resistance is given as the combined effect of this 2 plus 1 plus 2 is found to be 5 ohm. So what is the equivalent resistance? The equivalent resistance of the given circuit is found to be 5 ohm. Okay. So moving to the next question, that is question number 12. If all the resistors shown have the values 2 ohms each. So what is given here? Also 2 ohm, 2 ohm, 2 ohm. There also 2 ohm. You are asked to find the equivalent resistors. Okay. So very clearly these three are connected in series parallel combination. Each is having 2 ohm, 2 ohm and 2 ohm. Here also 2 ohm. The resultant of this 2, 2, 2 is 3 times it is connected. 3 equal resistors are connected in parallel. The resultant will be R by 3, but R is 2. So the resultant value will be here 2 by 3 ohms. R by 3. R is 2 by 3, 2 by 3 ohms. Now the simplified circuit diagram is something like this. We have the terminal A, the simplified part here, let me drop it. This is your 2 by 3 ohm. Further it is connected to a 2 ohm resistor and hence to terminal B. So clearly these two resistors are connected in series, and hence the combined effect is found to be the summation of this, that is 2 by 3 ohm plus 2 ohm, or it can be written as LCM 2, 3 to 6, 6 plus 2 is 8 by 3 ohm. But in the options there nowhere it was given as 8 ohm. So after solving this we have RS is equals to, so writing them in the mixed fraction 3 to 6 and remainder is 2. So 2 by 3 ohm. Hence the correct option must be option number D, that is 2 by 3 ohm. Okay.